Hi, welcome back to our chemistry flipped classroom. And today we're beginning by talking about atomic theory. So we talked about elements and we talked about putting those elements and their symbols together to form compounds. And so today we're going to talk a little bit about the atom itself, about what we believe it is, the theory behind atoms. And we are also going to delve a little bit into the structure of the atom, what it's made of, and how they can vary. So we'll start back with the beginning. So in 400 BCE, Democritus, who's one of the Greek philosophers, believed that there's a basic particle, and he called it atomos, which is the Greek word for indivisible. Now, Aristotle comes after Democritus, and he thought that there were four elements: air, fire, water, and earth. But neither view could be supported by any kind of experimental evidence. So they're both just ideas, and Aristotle was more popular, so his idea stuck around for a long time, till about the 18th century. So in the 18th century, we began being able to do some chemical experiments and really to measure mass accurately and to do different experiments to learn things about masses. So this is the beginning of atomic theory. So the first thing that is one of the underlying foundations of atomic theory is this law of conservation of mass. And you're probably familiar with this law. It says that matter is not created nor destroyed in ordinary chemical reactions. So this is generally credited to Antoine Lavoisier in 1774. He says, rien ne se crée, rien ne se perd, tout se transforme. And that's really just a way of saying nothing is lost, nothing is created, everything is transformed. So that's the law of conservation of mass. That is one of the foundations of atomic theory. The next law that's one of the foundations of atomic theory is discovered by Joseph Louis Proust in 1794, so about 20 years later. And he discovers and documents that a chemical compound contains the same elements in the same proportions by mass, regardless of the size of the sample or the source of the compound. And so this is known as the law of definite proportions or the law of constant composition. And so this law gets scientists thinking, why do they combine in these same proportions by mass? What is special about these particular proportions? And so this leads us to Dalton's model of the atom. There's one more law, but we're not going to worry about that one. So Dalton discovers a third law that we call the law of multiple proportions. And from that, he comes up with his model of the atom. So John Dalton is an English teacher in the late 1700s. He summarized the results of his own experiments and those of others. And he combines this idea of the elements, the individual elements, with the idea of atoms into what he calls atomic theory. So let's take a look at Dalton's atomic theory. So it's proposed in 1803, and he says that elements consist of individual particles called atoms. And there are 5 hypotheses in his theory. The first one is that all matter is composed of tiny particles called atoms. The second one is that all atoms of an element are identical in mass and fundamental chemical properties. So he's saying all atoms of any one element are the same. His third hypothesis is that atoms cannot be subdivided or destroyed. And his fourth one says a chemical compound is a substance that always contains the same atoms in the same ratio. And the final postulate is that in chemical reactions, atoms from one or more compounds or elements combine, redistribute, rearrange to form one or more new compounds, but that the atoms themselves do not undergo a change of identity in chemical reactions. So this is Dalton's theory. It's a theory. Unlike Democritus, this is not just an idea. It's a theory. It is supported by data, by evidence. It's tested, it's verified by lots of different scientists. And while it may be evolving and pieces of it may change, may be disproven, it is supported by data. Okay, so that's Dalton's atomic theory. He says that the atom is indivisible. So that's one of the first things that we're going to kind of pick on. So By ordinary chemical means, can an atom be divided? No, but you already know that an atom is made up of smaller particles still. And so we're going to talk a little bit about what's inside the atom, and it's not really indivisible. So inside our atom, we have positive and negative particles, and we call those positive particles protons, and the negative particles electrons. We also have a third kind of particle that is uncharged, and we call that a neutron. So these three subatomic particles make up our atoms. Subatomic meaning below the atomic level. So the mass of a proton is about 1 atomic mass unit, and it has a +1 charge. The mass of a neutron is also about 1 atomic mass unit, and it has no charge. And then we have the electron, and we say that it has a relative mass of 0. It's about 1/2000th the mass of a proton or a neutron. And so relative to those, it's effectively 0. And of course, it has a charge of -1. So we have positively charged, negatively charged, and neutral. And we have 2 that have a mass of 1 and 1 that has a mass of nearly 0. All right, so atomic number. So one of those subatomic particles is the proton, and the proton is the defining characteristic of an element. It is the number of protons in the nucleus of every atom of that element. So no matter where we find the carbon, it's always going to have 6 protons. If it doesn't have 6 protons, it's not carbon, it's something else. Phosphorus is always going to have 15, gold is always going to have 79. And those atomic numbers are the same as the number of protons, and we abbreviate atomic number with Z. The atomic number is the identifying characteristic of the element. It is the number of protons in the element. If the number of protons changes, the element changes. But the number of neutrons can change, and that does not change the identity of the element. So protons define the element, number of protons define the element, but number of neutrons can change. Number of electrons in a neutral atom is always going to be equal to the number of protons. All right, so if neutrons can change, we call those things isotopes. So an isotope is an atom of the same element that has a different mass because the number of neutrons varies. So if we look at hydrogen, the most common form of hydrogen is hydrogen 1. It has 1 proton, 1 electron, no neutrons. So it has 1 proton in its nucleus, and that's it. And it has a mass of 1. If we look at hydrogen 2, also called deuterium, we still only have 1 proton, that's hydrogen. We still only have 1 electron, it's still neutral, but now we've added a neutron and we've doubled the mass. And now in our nucleus, instead of just having a proton, we have a proton and a neutron. And when we get to hydrogen 3, we still have only 1 proton, only 1 electron, but we now have 2 neutrons. So we now have 2 neutrons and a proton in the nucleus, and it has an atomic mass of 3. So isotopes of an element always have the same number of protons, same number of electrons, but they vary in their number of neutrons, which causes them to vary in mass. So let's talk about mass number. And mass number is the number of protons and neutrons in the nucleus of an isotope. So mass number is number of protons plus number of neutrons. So if we were to look at oxygen here, it tells us this is oxygen, and it tells us that this isotope of oxygen has 10 neutrons. Well, oxygen always has, we look at our periodic table, 8 protons. We can look at the atomic number on the periodic table, and it'll tell us that oxygen has 8 protons. Since it has 8 protons, it must also have 8 electrons, and our mass number is protons plus neutrons, so that's going to be 18. And so we name this nuclide, this isotope of oxygen is named oxygen 18, and that 18 tells us its mass number. So if we look at our next element here in the table, we can see that we have 33 protons and 42 neutrons. So we look at our periodic table and we find the element with the mass number, or sorry, with the atomic number of 33, and we find that it's arsenic. We have 33 protons. We must also have 33 electrons, and 33 plus 42 gives us a mass number of 75. So we're going to name this one arsenic 75. So I'm going to ask you guys to go ahead and pause here and see if you can figure out this next one. So look at your periodic table and see number of protons is your atomic number. So look that up and see what element that's going to be. So pause now, fill out your chart, and then let's unpause and come back. We know the mass number is 31. We look at our periodic table and we can see that the element with the atomic number of 15 is phosphorus. So this must be phosphorus 31. And since it's 31, we know that it must have 16 neutrons because 31 minus 15 gives us 16. Okay, and we'll pause here for the evening, and we will chat tomorrow about isotopes. As always, if you have any questions, please let me know, and I look forward to seeing you in class.